Hey everyone, I'm James, and in this talk I'm going to show you how you can build your own HTTP router for Deno, a new JavaScript runtime. To introduce myself a bit more formally, I'm a senior software engineer at Evergreen Life. I'm the organiser of this meetup, so if I seem familiar to you, that's probably why. So let's jump straight into things. First of all, I should preface the entire talk with the fact I love Node. Being able to write JavaScript outside of the browser is a huge productivity win, having a shared language across both environments, to put it in another term. That said, Node definitely has its flaws. The lack of parity between the browser environment and Node's execution environment, I think this is a critical one. So although they both run JavaScript, the differences in the core APIs make it quite difficult at times to reuse code. There's no granular permissions model, or well, really there's no permissions model in Node. So you write your script, you run it, and it can do anything and everything it wants to do. So from spawning tens of thousands of TCP connections to accessing and modifying the file system. As if you have it in your script, Node will just happily obey, and there's no way to really control that via the process. Node modules. I think this also ties into the module resolution algorithm of CommonJS as well. So you can give it a path, say require glob, and it would have to know to look for glob in Node modules versus giving it a relative path. So really this is 2 points. This is Node modules and CommonJS's module resolution algorithm. This is a particularly big bugbear of mine, Node.js. So this is the tool in Node that compiles native bindings that can then be called via JavaScript, which is a great feature in itself. The problem is every time you change Node version and consequently V8 version, you have to recompile those bindings. If you're a front-end developer and you use or have used Node SAS, and you change Node version, and when you do npmi or try to start your project, you get a load of C++ errors spat out at you, this will be why. So if only there was some alternative JS runtime, one that really mitigated a lot of these problems. Well, I'd like to introduce you to Deno. Deno is a secure runtime for JavaScript and TypeScript with V8, Rust, and Tokyo. Now, one of the key modules in the standard library is standard/HTTP. Standard/HTTP includes a HTTP server implementation, much like Node's http.server. This renders Deno, like Node, a solid contender for particular types of backend service. So we're going to build our own HTTP server, and on top of that we're going to build our very own router. The router we're going to build is mostly going to be inspired by Reno, which is a routing library for Deno's HTTP server that I've been working on for the last year. Yeah, let's do this. Okay, so I have created a directory, Deno router, and currently it only has a .vs code folder within it. I'll go into this briefly, but otherwise it's empty and we're in a position to get started. Now, a good starting point evidently would be to make sure we actually have Deno installed. Now, it is installed on my system, but I'm going to act as if it isn't to demonstrate how simple it is to install. So if you don't have it on your system already and therefore can't upgrade from a previous version, it's a case of running this shell script that is provided on the official Deno documentation. So you're effectively curling it, or you are curling it, and then you're just passing it into the shell interpreter. Okay, so it's installed, and if I type Deno /version, hopefully it should tell us what version we have installed and some other information. Okay, cool. So Deno 1.5.2 is installed, and that's using TypeScript 4.0.5, so that looks great. Now, we need to bring in a dependency to be able to define our HTTP server. And a best practice that's recommended by Deno and is used in most of the prevalent Deno-based open source projects out there is to have a single module that acts as an import and export point. So we're going to create a file called deps.ts. And in this file, we're simply going to import and re-export the HTTP module. Okay, so this should be fine. However, TypeScript is complaining that we're importing a path that ends with the .ts extension, and of course, by default in TypeScript, given it conforms to Node's module resolution algorithm, this isn't valid. But given Deno, wonderfully so, doesn't have a module resolution algorithm, we need to override this behavior. So a few moments ago I mentioned this VS Code directory, and contained in said directories is a set of workspace settings. Now you want to install the official Deno extension for VS Code, and once you've done so, you can enable it, and this will allow you to import paths with the full extension. So let's change this to true. Now if I return to my dependencies, it isn't complaining about that particular error, that's great, but now it can't find that particular module locally, and that's absolutely fine because we haven't brought this into the file system yet. So what we can do for now, in order to bring in this module and its associated types, is run deno cache deps.ts. This is bringing in that module and every associated dependency. Now, it can sometimes be a bit slow to update, but if we close that file, reopen it, there we go, it's not complaining. So, and you can see as well it's resolving to our local cache. So now we're in a position to actually write our server. So now I'm going to create a server.ts file. And now I'm going to import listen and serve from the HTTP module, or more specifically, the export from our deps file. So notice we have the / at the beginning to denote it's a local import, and again we have the full extension. So now let's define our server. Cool, so we await listen and serve. Note that Deno supports top level promises, bind our server to port 8000, and we just respond to absolutely everything with hello Deno. So let's try and run this and then actually hit it. Okay, so naturally we'll want to run deno run server.ts. Okay, so this is interesting. We get a permission denied error because we haven't specified the allowNet flag. So this is that thick permissions model kicking in. So let's try this again, albeit with the right flag. Okay, it looks like it's running. If we curl our server, look at that. I mean, I should probably have a new line at the end. And nonetheless, we can hit our server and get our response. So it's that trivial on the surface to create a simple HTTP server. Our next natural step will be to make our application more complex. So I'm going to introduce a simple in-memory data store that contains some messages, effectively an array of strings. Okay, cool. So fast forward, I've created a simple in-memory data store based upon an array that just contains those messages as strings, and it abstracts them with an API for returning the messages as a shallow copy, and also to add a new message. And note that we're also importing v4 from deps, and this is simply the UUID module that Deno's standard library also provides. So we're generating version 4 UUIDs for the messages. Okay, so let's start building a more realistic service based upon this data store. So what we'll do is expose a messages endpoint, and that will return the entire list of messages as a JSON string. We need to handle the correct path. It's important to highlight that response bodies are either strings or bytes or Deno readers, which we won't get into for this talk. And I think the default character encoding is UTF-8, which is unsurprising. So given we need some kind of string to keep it brief, we need to serialize our entire messages array. So we'll need to invoke json.stringify. And of course, we need to call datastore.get to retrieve our messages. Let's not forget to set the content type header, given that this is a JSON response after all. A bit of trivia as well, this headers constructor is the same headers constructor that you'll find in the browser that's associated with the Fetch API. And also, we need to handle the case where our URL doesn't match /messages, in which case we need to return a 404. And we can remove this call as well. So let's restart our server and hopefully see our new endpoint in action. Note that I switched to Postman. It just makes it a bit easier for consuming JSON resources rather than having to set the headers within curl and parse it on the command line. So let's hit our new endpoint. Cool, so we have our JSON array of messages, and if we look at the headers, we can see the content type is application/JSON. And then to test our not found logic, if I put any old gobbledygook as the path and go to the response, we can see we're getting this not found error and the server is responding with HTTP 404. Okay, great. Okay, so we have very basic routing logic and we can retrieve messages. Now let's add some logic against our existing messages endpoint to add new messages to our in-memory data store. Now we need to discern between the various HTTP methods as long as the request URL is /messages. We've moved our existing logic for getting messages into this conditional statement. We need to handle the post, and on post we'll create a new message, forward the message to our data store, and return the ID in the body. For consistency with the JSON response bodies, we're going to also accept JSON request bodies. Now, request.body in Deno is a Deno reader, so we need to read this, which will give us a uint array, which we can then convert into a string and pass to json.parse. And of course we need to make this handler async now, because we're using the await keyword. And finally, if it's not a method we support, we should return HTTP 405, method not allowed. Okay, cool. Let's restart our server and try the existing endpoint, our new one, and this new method not allowed logic. Okay, so non-existent endpoint still works. Retrieving messages still works. If we try a method that isn't allowed, like patch, lovely, we get HTTP 405. And now let's try creating a new message. So if we go to our body, oh, it's already JSON. This is one I created earlier. So we have a contents property. And let's say hello again from MancWeb. Now, hopefully, if we post this, we get an ID back. Excellent. And if I change the verb back to get and make that request again, we should see our new message in the overall array. Excellent, it's there. Now, technically, we have a server that works, and it has a set of endpoints and a well-defined contract, but let's be honest, having these imperative conditionals, it's not going to scale well at all. As your application grows and you have different endpoints, I should add as well, in the context of writing a monolith is where this makes the most sense. As we add more endpoints, more root handlers that behave differently according to different methods, and some need to parse and serialize JSON, a lot of this logic is either redundant in the sense we're repeating ourselves over and over, or we're having these nested conditional statements, and it's not going to scale well. in terms of the architecture of the application as we add more routes. So really, in a production scenario, this is where we'd introduce a routing library. In our case, I promised I was going to show you how to write your own, so that's what we're going to do right now. So what would our ideal routing API look like? So this is effectively how I designed Reno. So we have this declarative routes mapping where you specify a particular path to which you want to bind, and a request handling function that will handle that endpoint. Now, this doesn't have anything particularly special in terms of handling particular methods or parsing our JSON body or serializing them, but we're going to build on top of this contract, and we can see how we can effectively rebuild our service in this declarative, composable, and super reusable way. So for now, let's take our existing handler and we'll keep the imperative checks for the URL and for the method. But instead of calling rec.respond, we'll return a response object from our function that will then get passed to rec.respond, and that keeps our route handlers pure. So let's give that a go. Okay, so it's a starting point. So let's write our router that at a simple level will take in a request, look up the URL against our map, and invoke the handler. So I'm going to define a route handler type. That's a function that takes a regular Deno server request and returns our own response type. Next, let's define the function that creates our router. Now our router will return a function that can take a Deno server request, and we'll use this server request to perform a lookup against the routes and invoke the one for the given path, or return a 404 if there's no handler for that given path. I'm also going to put the route definitions into a map for easier lookup. Now I'll export this function and then invoke it within my server. Now notice that routes can't be passed as this particular parameter, and that's because, as I mentioned, we're going to make our route handlers pure, whereas our current one is still calling rec.respond. So let's remove that call and return the response object directly. Also, given our routes are a tuple, we need to type this more strictly to hint to the TypeScript compiler. And we need to export routes handler. Okay, so let's build this and make sure it's still working. Okay, on the surface, still looking good, great, but we can still do better. One thing we're doing a lot of is, not one thing we're doing a lot of, but one thing we're doing that's still quite imperative is this checking of the method. Now, because our route handlers are pure functions, we can create a higher order function, or a higher order route handler if you will, that will allow us to run different subhandlers based upon the request method. So let's sketch out what this API will look like. Okay, so now we have something more declarative and better abstracted. Let's actually implement this. One key thing, I'm going to lift this bindings type so I can reuse it. So this is going to be pretty much the same as the main router, only it will check against the request method, not the URL. Now let's export this and import it into our server. And hopefully, excellent, it detects the types. Looks happy. Let's try to run that. And if I try a disallowed method, excellent. And a non-existent path still returns a 404. Excellent. So again, we're getting into slightly more declarative and reusable and pretty much composable territory. Well, I think the next point to address is the response objects we're returning from our get and post handlers. So there's a lot of duplication here. We're defining a headers collection with the exact same header key and value, and we're stringifying the body in both instances. So we should add a helper that will do this for us. So I'm going to add a new function called JSON response. And this is going to take a generic parameter because it can serialize any type of object, but we won't specify this directly, rather TypeScript will infer this for us. Okay, and now we can use this in place of returning our hard-coded response objects. Okay, so things are looking a lot better, but one thing that could be better abstracted is the parsing of our JSON request bodies. So again, given the pure nature of our route handling functions, we can create a higher order function to parse JSON bodies for us. So let's give that a go. Now, what we'll want to do is associate the parsed body with the request, but because server request is a closed type provided by Deno, we'll need to create our own JSON request type that we can then pass to the wrapped route handler, and also we'll need to make our route handler type accept any sort of request. So now let's use this type in our outer parameter. So in Reno, I was a lot more selective with the properties when creating these types, but for the purposes of this demonstration, we can just work around it with this type assertion, and we can just mutate the request directly. Okay, and now let's integrate with that in our post handler. So notice that JSON request is inferred as the type of request, although I should pass in the type of the body, and I should define a type for that body as well. And now it has that type, so we can destructure the contents as so. So again, we've abstracted away that functionality in a reusable and composable way. So let's make sure this still works. So far, so good. Okay, that works. So we've gone from having a bunch of nested conditional statements to having this nice declarative means. I mean, perhaps I'm biased when I say nice, but nonetheless, we have a declarative means of determining path bindings and the logic that should handle them. And then we can use higher order functions to complement our route handlers with different behaviors. Now, there's one more thing I want to show you. Now, of course, this is far from complete as a router. We're missing things such as path parsing. So if you want to use path parameters, query param parsing, form data support, streaming data. So not to, again, to shield my own products, but I should iterate that Reno supports all of these things. For now, there's just one more feature I want to show you, and that's how the nature of route handlers being these pure functions that always return a particular type of output for the given input allows us to bring together reusable behaviors in an extremely composable and flexible way. Okay, so I'm back and I've just added two small things. So the first is I've got this dummy auth abstraction that really in production would do a lookup against an API key table, or might check for a session or verify JWT, etc. But for the purposes of this demonstration, we've just got this hard-coded API key. And then in server, I've written a higher order route handler to log requests. So you can see it takes a route handler, it returns a route handler that logs the request and calls the inner handler. So what we're going to do is for all of our routes, we're going to use this higher order function, and now I'm going to write another one that invokes the auth wrapper to ensure that the request is authorized to view the messages list. And then I'm going to use a compose utility to bring them together into one higher order route handler with which we can wrap all of our routes. So let's write the second higher order function for our authorization. And now I'm going to bring in a small compose module that someone's published onto the Deno registry and place it in our deps module. Okay, so no, I've used this recently, so it's actually already in my cache very conveniently. Okay, so now let's compose these two higher order route handlers into a single composed higher order route handler. Okay, so let's restart our server and hopefully we should now have some logging and some authorization in place. Cool, so it logs that we're not authorized and it also logs the request to standard out. So let's get past this authorization. And excellent, now we can access it and it still logs. Let's post one. Okay, it publishes. Let's get, and it's there. Excellent, cool. So, look, in production, you'd obviously want to use an existing routing library or framework as they're typically well tested, have many contributors across the community, and are just generally more reliable and time saving than writing your own router from scratch. But I hope nonetheless I've shown you that Deno gives you a lot out of the box, and with TypeScript and a route handler primitive that is intrinsically composable, you get this really nice functional contract that allows you to compose behaviors with constructs that are just intrinsic to JavaScript and TypeScript. So, yeah. A long way to go, but I think it's a solid starting point. Now for some closing thoughts. Deno, like Node, provides a well-featured standard library. Its first-class support for TypeScript encourages the design of easily integratable APIs. But what does the release of Deno mean for Node? It isn't clear at the moment. A lot of engineers are comfortable with Node and have no justification to make the switch. Node isn't going anywhere, in the words of Dahl, so we know it's staying put for the time being. Personally, I'm preferring the developer experience, and I hope others will too. And my final closing note, Deno is an anagram of Node, which might have been obvious to you from the beginning, but it took me probably the best part of 8 months to actually realise. Thank you so much for listening. You can check out the project on the renorouter.org by following the last link, and yeah, I hope you give it a go, and thank you.